About here is working with an infinite geometric series.
What?
And we're just going to figure out how many it takes to keep adding them through.
I like that. It's going on forever.
Quite literally.
Is that like? It's just especially who I am, right?
No.
You just stand there for hours. It's going forever.
It's like the good old joke. Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat. Pete fell out. Who was left?
Pete number no.
All right. So here's what's happening.
Oh wait.
If you take a look at what a geometric series looks like, you're taking a geometric sequence and you're adding them together. And what happens as you're adding them together, you start with 1/2 plus 1/4, you get 3/4. 1/2 plus 1/4 plus 1/8, it's a little bit more. 1/2 plus 1/8 plus 1/16, a little bit more, and so on and so on and so on. What's happening here is that these values can continually add more to them. But what they're doing is that they're approaching a specific value. They're kind of approaching an asymptote, if you will. Now, yeah, but we're not graphing this up. You don't have to worry about that. It's something you can get. You can get infinitely closer and closer and closer to touching, but you'll never quite get there. For example, here, this is like you can always take half of something, and you're still going to have something left. Okay. So if you add up all those bits and pieces as you go through with something like this, you're approaching 1. Okay. If you take that geometric series and you add that all up towards infinity, you're going to approach the value of 1. So what happens here in math is that we say that the infinite geometric series, it can be defined by a very, very simple formula. And it looks like this. The sum of an infinite geometric series is always the first term over 1 minus the rate. Yes. You have to remember one thing, though. The absolute value of the rate has to be less than 1. If it is greater than or equal to 1, the series has no sum. You cannot add it all together. Okay? There is no sum. So all we have to be able to do here is identify what R is and press a couple buttons on our calculator. So your infinite geometric series, the sum of the infinite geometric series is always going to be your first term over 1 minus your R. Okay? Let me show you an example. In this case, they're saying find the sum of the infinite geometric series as starts at 1, goes through infinity, of the following. That is written in the, I don't know how I'm going to put it, kind of like the standard form of the geometric sequence. First term, R, the n minus 1. Okay. So what's your value, what's your first term? 3. Your first term is 3. What's your R value? 0.7. So all you have to do is take 1, it's first term, 3, over 1 minus 0.7. What do you get? 10. You okay on that? Okay. Again, same idea. Find the sum of this, but what don't you know? Right away. How can you find it? Let me ask you this. What is R always going to be in a geometric sequence if the first term is 1? The second number. What's the second number here? What's your R value? There you go. So your first term is 1. Your R value is negative 1/4. Is the absolute value of negative 1/4 smaller than 1? Yes. So we'll just have a sum.
Yes.
So first term over 1 minus the negative 1/4. That's 2/5, I think. Again, the calculator presses the buttons, it'll spit that out for you. Okay? You guys are all looking like it's gonna get really difficult, aren't you?
Well, that's the thing.
If there's one thing when it's
Was that good?
is that it's gonna get more tricky.
Okay, what's the sum of this?
There's infinity, Mr.
How much?
I got 90s.
First term over 1 minus your rate. So it's 5 over 3/4.
Yeah.
20 over 3.
So
5.
Are you putting the 1 minus 1/4 in parentheses?
I did, so I got to see.
Are you supposed to?
Yeah.
Wait,
It depends on how you're typing. Are you typing with the fraction bar?
yeah.
You're fine.
Okay, well, that's what
All right, if you type with the fraction bar, you're okay. 5 alpha 1 minus 20 over 3. But if you don't, if you type it the way you were saying, just make sure you put that denominator in parentheses. Okay.
It's all right, Sam.
Okay? What do you have to figure out? Okay, what's 1/2 divided by -2?
4.
Is it positive or negative? Negative. So is the absolute value of negative 1/4 less than 1? Okay, so that means you take -2 and you divide it by whatever, and you get an answer. What do you get? Five over 2?
Would that be 1 plus 1?
I was, yes, thank you. Because the rate was 1/2, so it was negative 1 minus a negative 1/4. Yeah, so you get -2. Okay. All right. Have to do it to you.
No, I haven't.
It's
It's a
Oh,
How many?
Find the ratio. Find R.
Don't say that.
It's not that simple, is it?
it never is.
The sum is first term over 1 minus R. There are 3 variables there, correct? So that means we only need to have 2 of them to figure it out. Okay? Well, the sum is 10. First term is 4. Oh no, what do I do? Oh no.
They're on the sides, Mike. They were before. Oh, were they? What?
Okay, where'd you
What?
Where'd you get
2 steps.
All
right, from here, I divide by 10. Okay? Then I had 1 minus r. I added r and I subtracted 4/10, which is 2/5. 1 minus 2/5 is 3/5. There's your r. That's as scary as this gets. I'm not lying. Now, one of the things that we have not done, though, with this chapter so far, in sections 2, 3, and 4, we really haven't gotten into the word problem style that they have.
Oh.
We will get to those next week. We will talk about writing rules for recursive, and then we'll test out of this. We'll probably be done with this chapter by Thursday. Okay? Probably next Wednesday or Thursday without a problem at all.
So we're gonna do that Friday.
I don't know. Chapter 12.
Yeah, let's have some fun.
Chapter 12 is fun. It's probability and statistics. We get to play cards.
Play cards Friday?
When are you gonna bring on your blackjack?
Do we get to count cards?
Blackjack.
Yeah, you can count to 52.
That's not what I meant.
I don't tell you how to count cards.
I know how to though. We should play math.
What I want you to do, I want you guys to do on page 678.
Alex, now you have
Ladies and gentlemen, you got some homework.